Alright, hey everybody. Here's your last video. We got a quiz Wednesday. So let's do a little more reviewing. Looking up here, you know that this quiz is basically about two things. It's about arc length and it's about the area of a sector. That's it. So the formulas are pretty straightforward. You know, one main problem with the review that I gave you on Friday when the substitute was in for me is I think literally every single question is in degree mode, and you know there's going to be some that are in radians. So as I go through this, I'll change some to radians and we'll do them to make sure that you're comfortable with those. But all you really need to know is a couple formulas. If I'm in degree mode, then the formula for arc length is that arc length is equal to the arc measure as a degree, like an angle measure, divided by 360, and then multiplied by the total circumference, which is 2 pi r. Now the only change over here, if you're trying to find the area of a sector, is that area is going to be arc measure, still divided by 360, but now instead of multiplying by the circumference, you multiply by the area, so that's pi r squared. That's it. This is kind of the whole quiz in a nutshell, is these two formulas, finding length of an arc and finding the area of a sector. I mean, that's it. So looking here, it says find the length of the crust. Length of the crust means, if I'm a pizza, that you're just trying to find this distance that's on the edge of the circle. So that's an arc. We know we're doing arc length here, as opposed to over here where it says find the area of a single slice. Well, we've got a large pizza this time, and my little calculator's in the way. Let me get that out of the way, which I can easily do by clicking this button. Yeah. Alright, so what do we got? The large is cut into 8 slices, so you just go slice, 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 slice. I actually used to work making pizzas, so I'm good at this. Although I think the pizzas I made, we cut them into 6 slices. They're little baby pizzas. That didn't work at all either. Like this? Alright. Well, you get the gist. Okay, let me move that away. Alright, ready? Yeah. If you're just after that one slice, that's a sector. Anyhow, back to work we go. Let's just do it. Basically all we're ever doing here is plugging in to the formula. So looking here, we know that our arc length is just going to be the arc measure, which is, well, hold on. This, because it's a small pizza, was only supposed to be cut into 6 slices. So you could figure out these measures. I guess let's just do it. You know there's 360 degrees in a circle, so dividing that into 6 equal slices would mean that each slice is 60 degrees. So if that angle is 60 degrees, then the arc is 60 degrees. So you can plug that in. 60 degrees over 360. Now we're going to go 2 times pi times our radius. Now the radius of the small pizza is 6 because the diameter is 12. So 6. Alright, well, I can divide these by 10, and then 6 over 360 is, or 6 over 36 is 1/6. Now we should have known that from the get-go, because obviously if the pizza is getting cut into 6 pieces and you're only interested in the length of one of those, that's obviously 1 out of 6. So it's no surprise that that fraction came out the way it did. This is now 12 pi over 1. And then you multiply tops by tops, so 1 times 12 pi is 12 pi. Bottoms times bottoms, 6 times 1 is 6. And then you reduce if you can reduce. 12 divided by 6 is 2. And we still have the pi. So 2 pi. These are inches. That's it. That is how you find the length of that arc. Now switching over to the sector area, we're going to do basically the same exact deal. Again, we could find the arc measure, but I hope you don't need to. I hope you know that what this is going to come out to is 1/8. We're trying to find one of these sectors out of 8. So you know it's going to be 1/8. But again, just to demonstrate, I could do 360 divided by 8 to figure out what the central angle is. So what's that going to be? 180 over 4, 90 over 2, so 45 degrees. So if we did go 45 over 360, that's fine. You can go pi times the radius squared. This is the bigger pizza, 20-inch diameter, so that's 10. Well, yeah, 45 over 360 does reduce down to 1/8, just like we thought it would. 10 squared is 100 times pi, so 100 pi. I still like to just put this over 1, just so I can line everything up nicely. Now, multiplying the numerators is obviously 100 pi. Multiplying the denominators is 8. Now I want to reduce, and I'm still saying that the easiest way for you guys to reduce is probably just to chop in half. Anything that's even, chop it in half. So you get 50 pi over 4. But then those are still even, so that becomes 25 pi over 2. And these are going to be square inches, because this is an area now instead of an arc length. But there you go. There's two examples of the two main ideas of this entire quiz. This is it. Okay, moving on. So here's another one. Just like before, I'm asking you to do a little bit of both. If you read this, it says find the length of major arc, ADB, but then it also says also find the area of the shaded sector. So there's two different things to do here, and we'll start by finding the arc length. And we'll find the arc length the same way we always do. Arc length has a formula, and it's to take the arc measure, divide it by 360, and then multiply by the circumference. So that means the measure of ADB, oops, that's not right, the length of ADB is going to be its measure, which, by the way, it says it right there. We're talking about this 240 degree major arc. So in goes 240. That's supposed to be 240. This just got connected at the top. There you go. And then times the total circumference, so 2 times pi times 24. Alright, so let's say real fast that you're a kid who's not so good at reducing fractions. We'll pull up your calculator. Chances are you've got a calculator that's good enough that it can handle this. So I showed you before, I'll show you again. You're going to type in 240 divided by 360. And I like to hit enter. Just hit enter and get a decimal. Then you go into the math menu, click math, and choose convert to fraction. And what it's going to do is give you back a fraction, but instead of giving you the fraction you entered, it gives you the reduced form of the fraction that you entered. Someone did point out to me earlier that you don't have to hit enter. Maybe it's a little faster to just enter the fraction and then go math frac right away. And it just goes right to the answer. It never shows you the decimal, it just goes right to the answer. That's fine, whatever, I don't care. Anyway, this fraction should reduce down to 2/3, so hopefully some of y'all will find that helpful. I'm still saying that, you know, another way to do this is just to do it by hand. Some of y'all don't have calculators, so you'll have to. But we talked about numbers that end in 0 are certainly divisible by 10. So dividing by 10 gives 24 over 36. Now they're even, so that can be 12 over 18. Those are still even, so that's now 6 over 9. Now 9 is not even, but these numbers are now so small that I think you guys can easily tell that they're both divisible by 3, and that gives 2 over 3. So, okay, it took me a few steps, 4 steps, but it was wicked easy. I'm just chopping in half, chop, divide by 3. And you get there. You get to that sort of final simplified form. Now in here, you see that's going to be 48 pi. Alright, again, one more trick is you guys can multiply first and then reduce if you want to, but you can also cross-reduce in this position. So if 3 and 48 have a common factor, you can reduce that right now. And they do. They're both divisible by 3. So 3 divided by 3 is 1, and 48 divided by 3 is 16. So now I'm working with smaller numbers. The 1 times 1 in the denominator is just 1, obviously. And in the numerator, I'm getting 32 pi. So 32 pi over 1, that's just 32 pi. Lose the over 1. And give me my units. These are inches. So that must be the length of that there arc. But that's not the end of it, because remember we were supposed to also find the area of the shaded sector. So let me lock this down. Lock. Let me grab all this junk and shrink it. Put it over there. Alright, now we got plenty of room to do the rest. Okay, so to find the area, we're going to take same approach, where the same approach means, write out the formula. It's still going to be arc measure over 360, but instead of 2 pi r, it's now pi r squared, because we're after an area. The other thing that switches is, we're not interested in this major arc anymore, we're interested in this sector. And this sector is defined by this minor arc. And hopefully you remember that if a whole circle is 360 and you already know that this chunk is 240, then we saw on the last quiz that we're just going to do 360 minus the 240 to be left with 120. So we know that's the measure of this arc. So we'll plug that in, 120 over 360. We also know that our radius is still 24. Alright, divide by 10, chop it in half, 6 over 18, divide by 6, 1 over 3, it's 1/3. 24 squared is something pretty big, 576, throw that over 1. Here, I guess you just grab a calculator and you check to see if these things are even divisible. So where is my calculator? You just type in, alright, 576. Divided by 3, and I think that just comes out cleanly. You get 192. So you know then that when you multiply to get 576 pi over 3, you know that those are just reducible down to 192 pi. Exactly 192 pi. And again, these are not inches, these are square inches, because again here we were solving for area, not length. And area is always going to be square units. That's it though, that's number 2. And now we can do 3. 3 is just saying find the area of the shaded sector below. So this is a pretty straight up problem. You'll say area equals arc measure over 360 times pi r squared. Our arc measure, well if the central angle is 80, then the arc is 80, just like on the last test. That's going to be over 360. We've got another really big radius, 36. But you'll have a calculator, so to find out what 36 squared is, you do 36 times 36, no big deal. To reduce this, I'm going to divide them both by 10, then I'm going to divide them both by 4, I think is my best bet. If I divide by 4, I get 2 over 9. So 80 over 360 as a fraction is 2 over 9. 36 squared, I don't know, time to just ask the calculator. 1296. Okay, this looks like a good problem to just use your calculator on, so let's do it. Whoops-a-daisy, second quit, clear. We're typing in all of this. Let's just do 2 times 1296. That's our numerator, 2592 pi. And that's all over 9. So at this point, if you're wondering if this reduces, just type this part into the calculator. Remember, leave the pi out of it. The pi will mess you up. But do the 2592 divided by 9. See what that is. Oh, it just came out cleanly. So since it came out cleanly, that means we just reduce. If this came out to an ugly fraction, we could use the old math frac trick, but we don't need to, because this just comes out to 288 pi. And since we're talking about area, these are going to be square inches again. And that'll do it. That's number 3. So here's 4. 4 is only different in that you have to do a little bit of work to figure out the central angle for yourself. And by a little bit of work, I mean just a tiny bit. It's really not that bad. But we're going to use the same formula. Our area is going to be arc measure over 360 times pi r squared. All right, so what's the central angle? Well, if this piece is 90, but the other piece is 120, then to find the total measure of the angle, you're just adding those up. So it's going to be 210. Then we're going pi times 6 squared. So this should be not a big problem. I can divide by 10, and I get to 21 over 36. Those are both divisible by 3, and so you get to 7 over 12. So that's a pretty ugly fraction, but no big deal. I'm going to square the 36, or square the 6, and I'll get 36 pi. Check that over 1. And this is a spot where you guys can see that it's definitely worth it to cross-reduce. If you had to multiply, well, you don't know what 7 times 36 is, but you can definitely divide the 12 into the 36. That makes 1. This is now 3. Now multiplying across the top gives us 21 pi, and the denominator just gives us 1, so we don't need that. Simplify that. This was area, so this is square centimeters. And that's another one down. Now we get to 5, and these were the ones that are asking you to find basically what part of a circle are you dealing with this angle measurement. So 75 you can probably visualize. 90 degrees would be here, right from here to here. So 75 would be a lot of that, but not all of it. So basically, what part of a circle is just this slice here? And so hopefully you can tell it's going to be a little less than a quarter. It's going to be a little less than 25%. How do you just find it though, numerically? Well, numerically you just do 75 divided by 360. And you reduce that fraction. And if you've got a calculator, then this is no work at all. You just type those numbers in. So 75 divided by 360. I'm even just going to go ahead and hit MathFrac right away. It's 5/24. So this answer is 5/24. That's it. For part B, you just do the exact same thing, but this time with 165. So 165 divided by 360. What is that? It's about half. So MathFrac. Sure, 11 over 24. All right, what about 150? If you want the practice, you could do these without your calculator. You go 150 over 360. Those are both divisible by 10, then they're both divisible by 3. So you land on 5 over 12. And that's the answer. That's what it is. And so for 15 degrees, well, they're both divisible by 3. You'd get 5 over 120. And then 5 goes into 120. So you get 1 over 24. And lastly, 220. You're going to divide them both by 10. Then you're going to divide them both by 2. You get 11 over 18. So all of these fractions are basically just the fraction that would put at the beginning of our equation, right? Where our equation says do arc measure over 360. That's what all these fractions are. They're telling you what part of the circle are you working with. So if you wanted to find the length of a 220 degree arc, you know that it's 11/18 of the whole circle, 2 pi r. You'd multiply and you'd get your arc length. Okay. So number 6 is the only place where you start seeing radian measures. And for this we said that 360 degrees on that scale is exactly the same as how many radians? And we said the answer to this question was 2 pi. So 360 is the same as 2 pi. That means 180 would be the same as 1 pi. That means 90 would be the same as pi divided by 2. 60 degrees would be pi divided by 3, etc., etc. 45 degrees is pi divided by 4. But there's a whole bunch of little angle conversions. The only one you really need to know is that 360 and 2 pi are the same thing. So now knowing that, to find this fraction, wouldn't we just take the 7 pi over 6? That's the part of a circle, and you divide it by the whole number of radians in a circle, which is 2 pi. Now the way I think about this is this fraction bar represents a division problem. So 7 pi over 6 divided by 2 pi. That's what we're trying to solve. Now I put the 2 pi over 1, and I would remember back to the olden days that the rule says leave the 7 pi over 6 alone, and then instead of dividing by this fraction, multiply by the reciprocal of that fraction. Suddenly you've got a very doable problem. This would be 7 pi times 1 divided by 6 times 2 pi. And those pi's cancel, so you get 7 over 12. Again, what is this? Well, that's the fraction of a circle that this thing represents. 7 over 12. Okay, let's do B and C and D and E. If you guys will forgive me, I might just go through these kind of fast, but it would be 10 pi over 3. I'm dividing by 2 pi, which essentially means I should multiply by 1 over 2 pi. Again, I'll watch these pi's cancel out. I can cross-reduce the 2's, and I end up with 5/3. So that's the answer to B. B is 5/3. And then C is pi over 10. All right, so again, to convert, I guess we're multiplying by 1 over 2 pi. So you get pi over 20 pi. And when the pi's cancel, there'll still be a 1 up there. So you get 1 over 20. That's a very small chunk. Pi over 10 is a pretty small chunk. D. 3 pi over 4. Alright, I'm going to multiply that by 1 over 2 pi again. That's giving me 3 pi over 8 pi. And if you cancel the pi's, then your ratio is 3 to 8. Alright, and then lastly, this one is a little different, but no, it's really not. We're just going to go 2 radians. Notice it's the only one that doesn't have pi in it. 99% of radian measures are going to have pi in them, but they don't have to. You could have a whole number of radians. So that's what's happening here. So I'll go 2. I'll divide it by 2 pi though, the same way I divide everything else by 2 pi. And the 2's would cancel. I would get 1 over pi as my ratio. And that's it. Let's do some more. So finally, here's where you get into just a bunch of more straightforward practice problems. So I think what we did in class was I changed this 75 into a radian measure, and it was like 5 pi over 24. I don't remember. Let's cheat. 75. There's 5 pi over 12. So we can do a few of these where we use the radian measures, but I guess first let's do 7, and let's do 7 as is. So to find the area, your area is going to be arc measure over 360 times pi r squared, which means we're doing 80 over 360 times pi times 9 squared. Which means, if I start reducing, I'm going to have 8 over 36, which is divisible by 4, so I get 2 over 9. And that's getting multiplied by 81 pi. Put that over 1. And you should see another chance to cross-reduce here. 9 and 81 are common factors. So 9 divided by 9 is 1. 81 divided by 9 is 9. Then we can see in the numerator we get 2 times 9 times pi, which is 18 pi. And the denominator would just be a 1, so leave it alone. This is area, so these will be square millimeters. Then when we switch over to arc length, we're going to say arc length equals the arc measure, which is 80, divided by 360 times 2 pi r, and the radius is 9. So this fraction is going to boil down to the same 2/9 that it boiled down to before. and we want 2/9 of 18 pi. Okay, so to finally simplify this, you could multiply first and then divide by 9. I still prefer to cross reduce. So I can factor out 9 again. Factoring out 9 leaves 1, factoring out 9 leaves 2. So we can see this whole problem is just 2 times 2 times pi, which is 4 pi. And this is what? Arc length, so this is millimeters. That's 9. And basically the rest are all really similar. So let's do, I skipped over 8 and 7. My bad. I don't know what I was doing. Whatever. Let's do, since we did 8 in class, sure, let's do 10, but let's do it in radian mode instead. So 100, 10 over 18, 10, 5 over 9, I think this is 5/9, 5 pi over 9, that is. Okay, so now, knowing this is radians, how do you change up your game? You kind of don't. You know that area is still what? Arc measure over 360 times pi squared. Alright, well, the arc measure is this radian measure, right? So you'd plug that in, 5 pi over 9. But hopefully you would remember, hey, 360 is a degree measure. I can't mix radians with degrees. So instead of using 360 down here, I should be using 2 pi down here. And then it's pi times the radius squared. We're letting the radius be 5, so 5 squared. Okay, so you got a little bit more work because you're supposed to actually clean this up. So this is basically a 5 pi over 9 divided by 2 pi, which if you throw that over 1 would be the same as 5 pi over 9 times 1 over 2 pi, which if you cancel the pi's is giving 5 over 18. So that's what this whole thing would become, 5 over 18. And then you're just multiplying that by 25 pi. And here's a good illustration of the fact that sometimes you just can't reduce anything. The 5 and the 18 don't have any common factors. The 18 and the 25 don't have common factors either. So you just multiply this out. You end up with 125 pi over 18. This is area, so it's square centimeters. That's that. Now for arc length, I do want to show you a little something. It would normally have been arc measure over 360 times the circumference, which is 2 pi r. But then if radians are coming into play, then there is no 360. There's 2 pi instead. At which point you realize pretty quickly that this 2 pi and this 2 pi would actually cancel out, leaving us with just an arc length that equals the arc measure multiplied by the radius. So with such a simple formula, mathematicians simplified it even more. They said arc length, let's just call that S. And no, I don't know why it's S. But the arc measure, well, we've got a perfectly good variable for measures of angles. We've always used theta, so let's bring theta back. And then just times r. So you could start this whole problem from right here if you remember this formula. If you don't remember this formula, then just go back to the other formula that you do know and just replace the 360 with 2 pi. You will get the same correct answer. So okay, we're solving. S is going to be theta, that's 5 pi over 9. Multiplied by the radius, which is 5. And if you throw that over 1, there's no simplifying or cross-reducing. So S is just going to be, that's the worst S of all time. So the arc length is just going to be 25 pi over 9. And that's centimeters. All right, before you shut this whole thing off, and we're up at a half hour, Two other things you should know are that you are given a couple delta math assignments, and some of these are going to be a little bit different. So let's do these together. This one is saying that GHI is 100, or HGI. So they're saying this angle is 100. Then they're saying the length of arc HI is 5 pi over 3. So this arc that's cut by that is 5 pi over 3. Then they're asking you to find the length of GH. Well, the length of GH is just the radius. All right, great. What do we know? Too dark. Meh, I can do that. I'm just changing the background color so that the yellow shows up a little better. But anyway, what's the yellow? It's this arc length. It's 5 pi over 3. And the angle is 100 degrees. And of course the green is the radius. Alright, if I'm trying to figure out this problem, then I guess I write down my formula for arc length. It would normally be arc measure over 360 times 2 pi r. And I guess it still is that, because we are still just working in degrees with the 100 pi. So the difference here is if we go to substitute in, we actually know the arc length already. That's the 5 pi over 3. And we also know the arc measure, it's 100 degrees. And we know 2, and we know pi. What we don't know is the radius. So here you've got a little algebra problem to actually dig out and find the value of r. You're not just plugging in for the arc measure in r and solving for the arc length. We did that a bunch of times, but you guys should know that of the three variables here, arc length, arc measure, and radius, of course I could give you any two of these and expect you to find the third. So how do I do this from here? The 5 pi over 3 you would just bring down. There's nothing to do with that for the moment. I would reduce this. These are both divisible by 2. So 5 over 18. I guess that's the best we can do. And then you've got this 2 times pi times the radius that we want to solve for. What would I do from here? I would remember that multiplying by the reciprocal of this will cancel it out. So I think pretty much right away I'm going to just multiply by 18/5. And that has the lucky property of killing off those. So I now have 2 pi as a coefficient on r. How's this color doing? I don't know. And over here the 5's will cross reduce, and then the 18 and this 3 will cross reduce too. So you're looking at a 6 pi. And now if you want to solve for r, you better divide by 2 pi. And the 5's will cancel, and 6 divided by 2 will be 3 units. Because they didn't actually give any units. Yeah, okay. I'm going to do just one more that's kind of similar to this. I mean, it looks really similar, but let's see what we got. It says PQ is 3. Okay, that's the radius. They're telling us the radius is 3. Then it says QR, the length of QR is 11 pi over 6. They're saying find the measure of the angle. QPR? The central angle. We got to find that ourselves now this time. So how's that going to work? Well, use the same old formula. Arc length is arc measure divided by 360 times 2 pi r. Alright, so what's the arc length? Well, that is something we know. It's 11 pi over 6. What is the arc measure? Well, that's exactly what we don't know this time around, is we don't know that arc measure. Then there's 2, then there's pi, then there's the length of the radius, which was given to us to be 3. All right, so what can we simplify here? I don't know. Trying to think of the best way to do this, but I think I'm going to just go ahead and clean up the right-hand side. So you'd have 6 pi over 360. And all that would be a coefficient on theta. So to solve for theta, you just have to get rid of this whole big block. To get rid of that whole big block, you might normally think divide by it. But since it's a fraction, you know that you'd want to multiply by the reciprocal instead. So on this side, we're going to multiply by 360 in the numerator and 6 pi in the denominator. And that's going to give us theta. Now, once we're here, how do you clean it up? Well, the pi's cancel out, that's for sure. 6 goes into 360 as well, so you get 1 and you get 60. But now, you can divide the 6 into the 60. That leaves you with 1 and 10. So what all is left? We've got an 11 and a 10 in the numerator. So that's 110. The denominator is just 1, so I don't need that. So I think that's it. That's telling us that that central angle is 110 degrees. Okay, so that's it. That's your whole review with a couple of extra problems thrown into. Well, I lied. This is not the whole review. But I just don't feel like doing 12 and 11, and I did 10, and I did 9. I did 8 in class. I did 7. You know what? It's basically the whole review. And tomorrow's another study day. So when you guys roll in on Tuesday, which is tomorrow, you can ask me a few more questions, and ideally there'll be plenty of extra time where you guys could work on a Delta Math or do something else in small groups. I think I heard someone say, let's play a Kahoot. And I'll think about it. I'll think about putting something together. But really, I need to be grading papers for you guys. So let me get off this recording and just say good luck, and I'll see you tomorrow.